For this project, we designed a foot for a 22-year-old, 5'7" and 160-pound transtibial male who wanted a foot that was both stylish and usable in sandals, in which he could take long walks on the beach. He's categorized as a K3 patient, which is described as community ambulatory with variable speed.
With our design, we wanted to take into account the aesthetic look of the foot. The original design was a little blocky with a triangular cut in the heel in order to place a rubber ball that would absorb impact from the initial contact portion of the gait. However, the amount of shear force placed in the angle was much too high and would cause the heel of the foot to shear off. Thus, we never tested this original design. Our next design took more of a natural foot look and considered the motion from the initial contact to the mid-stance phases of the gait cycle. We curved the end edge of the foot, allowing the client to rock onto the flat of the foot. However, with this design, the foot failed when testing at the terminal stance of the gait, as more pressure and load is placed on the toes, and thus the foot failed at both the midsole as well as where the adapter was attached to the foot.
For our design, we took into consideration of the pass flows, with the heel section being 3 parts alternating PLA where the adapter connected, cheetah, and then PLA for the heel. We allowed most of the force to be absorbed by the flexible cheetah print when taking impact from the initial contact of the gait.
As well as this, we added cheetah print to the midsole of the foot. This allowed the midsole to flex when going from the mid stance to the terminal stance of the gait. The midsole could also flex left and right, allowing for maximum deflection when walking on uneven terrains. During the walk test, our foot inevitably failed due to the amount of shear stress placed on the midsole of the foot when pressure was placed on the toes. The amount of area of contact between the cheetah and PLA portions of the foot was not high enough, and thus the shear force was too concentrated, causing the toes of the foot to shear off.
For future considerations, we would consider the amount of stress that is applied over the area. Reducing this ratio would be key in reducing the amount of stress and thus the failure of the foot. As well as this, we would need to reconsider more of the fit of the shoes because our foot is slightly too large and would need to be resized in order to fit the shoe more comfortably.